Welcome to another tutorial on MATLAB. In this tutorial series, we are looking into the MAAB guideline and how to implement MAAB guidelines in our models and in Simulink environment. In this particular chapter, we will be looking into the model architecture, and in the model architecture, we will be looking into the concept of mixed use of Simulink and Stateflow. So this talks about when we should use Simulink and when should use Stateflow. In the coming video, we will be seeing how to use flowchart and truth table and Stateflow. So first, let's look into this particular part. So coming to the use of Simulink and Stateflow, we have two options. So suppose your implementation involves more logical things. So in that case, you need to use Stateflow. So suppose you have one state, and from that state you want to go to another state, and this involves multiple logical calculation inside these blocks. Then you need to take the transition. Then in such a case, you need to use Stateflow. And as we already know that a Stateflow is a graphical logic building environment. So because of that, it becomes more easy to develop simple logics in case of Stateflow. And through that, we can visualize what the logic that is being developed. So it is more preferably to use Stateflow when there is a logical implementation happening in your model. There is one more possibility that is there while implementing the model, which is solving something continuously. So suppose you have some dynamic equation you need to solve continuously over time. So in such case, it is more preferable to use Simulink. So when you use Simulink, you can continuously calculate something over time, and you can generate the data which could be a time series data. So when you have more logical implementation, you use Stateflow. When you have more sequential or continuous calculations, then you can use Simulink. So coming to the next concept, this is use of Stateflow and Simulink together when both of the logics are complex. Like you have a complex logical operation, plus you also have a complex numerical operation. So in that case, you need to use both the tools together. So in this one, what you can do, whatever the complex logical operation that you need to perform, you need to implement it in the Stateflow. And suppose you have a state in the Stateflow, and there you need to perform a continuous calculation, suppose at this line in the state. Then in that case, you can do a function call. So a function call will be going from the Stateflow into the Simulink environment, and it will activate the Simulink model or the subsystem. Once the subsystem is getting activated, it will do all the necessary continuous calculation, and it will give some output into the Stateflow model or the logic that you have created inside. So this is how you can combine complex logical operation with complex continuous calculation, and you can implement any complex system using both logical and continuous calculation. Next, model advisory guideline for developing memory related operation. So when there is a need to store something, suppose you have a Simulink block or subsystem which is doing some operation, and based on that operation you are getting some output, and now you want to store that output into some memory location. Then in that case, you need to use some memory block which will be connecting Stateflow, and Stateflow will receive that, and the memory will be stored for future use. Suppose you have a variable x whose value got generated as 15, and now you want to store this inside the model, because in Simulink you cannot store anything. Because of that, you need to use the logical implementation part offered by Simulink, which is Stateflow, and in Stateflow you have memory blocks. So what you can do over here, once you generate the value of x, you can save it into some memory using the Stateflow, and when the next operation is needed based on the current value of x, then in that case you can use that value which is stored in the memory and then you can perform the operation which is needed to do the calculation for the Simulink model. In this case, you are storing something. So in that case, you need Stateflow and Simulink together, but here the use case is different. Next is designing more complex logics like the entire system. Like suppose you have a missile which you need to launch, or a rocket which you need to launch, and you have multiple stages inside this rocket, and the masses will be dropping over time when the rocket reaches the required altitude. So suppose this is the trajectory which it is following, and in between it is dropping the mass and the mass is getting updated. So here suppose the entire mass is m1, here suppose the entire mass is m2, and here suppose the entire mass is m3. Then in this case, the operations or logical operations that need to be performed depends on which type of system it is. For example, you can create multiple subsystems based on the masses, and you can create these like you can consider suppose this is for m1 state, this is for m2 state, and this is for m3 state. Then in this case you can activate everything based on the states. So suppose the mass is being dropped properly, then in that case you will be switching to the other state, and other state means here the next state, and based on that you will get some update inside your logical system, and that logical system will send a signal that we are at the status 1. That will send a signal or a function call, and that will activate the subsystem 1. So suppose now you are at mass m2 or state m2, this will get activated and this will get deactivated, and in this case you will activate this subsystem 2. Similarly, you can also activate the subsystem 3. You can change the behavior of the software over time based on the state. So these could be different varieties of equations that will be governing the control of this missile or the rocket. So coming to the model advisory check for these guidelines. So here the model advisory checks are not available for this particular guideline. Why? Because it depends on the user, how he is using Simulink and Stateflow. There is no specific automation that they have created to do this check. So due to the same, there is no model advisory check available for this one. You need to know this rule to implement it in a proper way to get the things done. So in summary, we have covered how to use Simulink and Stateflow, and we have also seen how we can implement complex logics using Stateflow, and how we can implement memory operations using Stateflow and Simulink. Here we have seen how to activate multiple system states, like different based on your state you will be activating multiple behavior in the system. That is all about this particular tutorial. In case you have any comment or query, please let us know in the comment section. It will be helpful for us to understand and clarify your doubts. Along with that, thank you for subscribing to the channel. It gives us a lot motivation to develop such content. Happy learning MATLAB. Stay connected. Thank you.